Hello students, let us try to understand the third law of thermodynamics. Okay, that is not too much important student, third law of thermodynamics, as it is extension of the second law of thermodynamics. Okay, so from the second law of thermodynamics, it is little bit elaborated from there. And what is the statement of the third law of thermodynamics, student? That is the entropy of a pure and perfectly crystalline substance. Pure and perfectly crystalline substance is zero at absolute zero temperature. Absolute zero temperature means what, student? That is minus 273 degrees Celsius. Okay. So at that particular temperature, that is absolute temperature, entropy for pure and perfectly crystalline substance is zero. Who gave the third law of thermodynamics, student? It is proposed by Max Planck, V. Richard, and that is Walter. And this is also known as Nernst heat theorem. Okay, Nernst heat theorem. Now let us read out little more statement, student. The first statement is what? The entropy of the perfectly crystalline substance in a pure state at absolute zero temperature will be the zero, right? It is impossible by any method, no matter how idealized it is, to reduce the temperature of any system to the absolute zero in a finite number. So what is the operation what we write? That is limit t 0 is equal to, and the at t0 absolute temperature entropy s equal to 0. Okay, so that is what third law imposes a limitation on entropy value but not leads to any new thermodynamics concept. It is an extension of the second law. Okay, so what they are saying, student, that is third law of thermodynamics, they are saying it is the extension of the second law of thermodynamics. Okay, and what it is imposing, student? Third law imposes a limitation on entropy value, limitation of on entropy value but not leads to any new thermodynamic concept. Now next point, at absolute entropy of a substance at a temperature T, absolute entropy of a substance at temperature T, how it is giving in the term of integration St. T is the absolute temperature, or you can say a temperature. So integration of lower limit 0 upper limit t cp upon t dt. Okay, what is meaning of this, student? Accurate determination of entropy St required that the heat capacity at constant pressure Cp must be determined accurately, but Cp cannot be determined accurately, measured accurately at absolute zero, that is minus 273 Kelvin, or around absolute zero. But Cp depends on temperature. At lower temperature, Cp is equal to Cv, that we know, which is calculated by d by. So let us see the derivation. So at lower temperature, here we are like writing, student, at lower temperature, what we are going to write, student? That is Cp is equal to Cb equal to ATQ, where A is constant. So St is equal to what, student? St is equal to integration of 0 lower limit upper limit t ATQ upon t dt. Okay, so therefore St is equal to Cbm upon 3, or St equal to Cpm upon 3. Now, what are the limitation of the third law of thermodynamics, student? It is not applicable for CO, N2O, NO, CS3D, H2O, H2, He, etc. Even at Kelvin, 0 Kelvin, they are not in pure state. This CO, they are not in pure state, or they don't have the perfect crystalline arrangement. So this is what the third law of thermodynamics, student. Let us see the some of the question based on it. What is the third law of thermodynamics in simple term? In simple term, third law states that the entropy of perfect crystal of a pure substance approaches zero. As the temperature approaches zero, the alignment of the perfect crystal leaves no ambiguity as the location and orientation of each part of the crystal. They are saying the simple term, however, the third law states that entropy of perfect crystal of a pure substance approaches zero as the temperature approaches zero. The alignment of perfect crystal left no ambiguity as to the location and the orientation of each part of the crystal. Okay, so that is what the third law. Is third law of thermodynamics is valid? Yes. Third law of thermodynamics hold for any system, classical or quantum mechanical. It basically states that absolute zero, that is 0 Kelvin or minus 273 degrees Celsius, cannot be reached, and that is entropy is zero, and that is entropy is zero. What does it means if entropy is zero? What does it means if entropy is zero? Zero entropy means perfect knowledge of state. Zero entropy means perfect knowledge of state, that is no motion, no temperature, no uncertainty occurs at absolute zero. This is what the no zero entropy means. Okay student, let us see some more concept. Third law of thermodynamics, in the another word, at absolute zero, that is 0 Kelvin temperature, theoretically all modes of motion stop, no vibration, no rotation and no transition. Thus the third law of thermodynamics states that the entropy of pure crystalline substance at absolute zero is zero. Okay, so this is all about the third law of thermodynamics student. There are not such problem which can be explained on the basis of this student. That is theoretically you can understand the third law of thermodynamics. Thank you so much for watching friends.